Namaskar. Welcome to the second lecture of the first chapter, that is Introduction to Control Problem. In this lecture we are going to discuss about open loop control system and closed loop control system in detail. So I am Hiren Kherala from Gyan Manjari Institute of Technology, Bhavnagar. Currently I am working as assistant professor in electrical engineering department. So let's get started. So in previous lecture we were discussing about the different kind of system. So we have discussed these three systems, that is energy conversion system, circulatory system, and what is linear control system. Also I have already defined the basic definition of open loop control system and closed loop control system with using one example of temperature control of our room. Now we are going to deal with detailed analysis of open loop control system. Here you can see the block diagram of open loop control system, where the input, or we can say the command signal, is given to the transducer that is going to convert the form of the signal, and that is fed it to a controller. Again that controller will control the signal and it will be given to the processor plant of the signal, and ultimately will get the output or controlled variable. Okay, so what is open loop control system? So it is nothing but any physical system which does not automatically correct for the variation in its output, that is called open loop control system. Now such a system can be represented by a block diagram given right here. Now in other words, when the output quantity of the control system is not fed back to the input quantity, such kind of control system is called open loop control system. Here you can see in the block diagram, your output is not going to fed again to the input. So such kind of system, there is no feedback path or backward path in this block diagram. You can see only the forward path is there. That is why such kind of system is known as open loop control system. So open loop control system, the output has no effect on the control action. In other words, we can say that the open loop control system, the output is neither measured nor fed back for the comparison with the input. That is what we are going to see in closed loop control system, where feedback path will be present. Now in open loop control system, the controlled variable remains constant for a constant command signal. Okay, so your output will remain constant as your input is constant. If your input is changing, your output is going to change for sure. Now here we are assuming that your external disturbance, your disturbance 1 and disturbance 2 we are considered, but as far as the disturbance part is concerned, let us assume this both are the disturbance is same. Okay, so we are assuming that the external disturbance or the condition will remain unchanged, but in case there is external disturbance or such kind of internal disturbance will be there during the operation, then the output varies in uncontrolled manner. Okay, that is one of the disadvantage of open loop control system, because if there is introduction to disturbance at any point in a process, your output will be going to vary in uncontrolled manner, and you will not going to have your desired output. Okay, and you cannot even check or just check whether your output is correct or not, because here we have not feedback path. So the output may be changed to any desired value by approximately changing the input signal. Okay, so if you want to just change your output, just ultimately change your input and you will get the output accordingly. Now the open loop control system satisfactory if such fluctuation can be tolerated, and our system components are designed and constructed so as to limit the variation in parameters or the environmental condition also included. Now, one of the practical advantage or the of open loop control system is it is very simple kind of control system. Let me take one example of open loop control system, that is washing machine. So what washing machine does, it is generally soaking, washing and raising the washer operate on a time basis. So the machine does not measure the output signal, that is the cleanliness of the clothes. So it will not going to change whether your clothes are clean or not. Okay, it is just working on the basis of time only. So if you set for 15 minutes, after 15 minutes your washing machine is not going to check the cleanliness of your clothes. Okay, so this is what open loop control system. So in open loop control system, the output is not compared with the reference input, and thus to each reference input the corresponding fixed operation condition. Now as a result, the accuracy of the system depends on the calibration, and in the presence of the disturbance the open loop control system will not perform the desired task. Okay, so here are some of the example of open loop control system. The first one is washing machine that we have discussed. So this we use in our home to wash and dry clothes. Internally the machine runs according to the reset time and doesn't depends upon the washing process, whether it is completed or not. Same way the electric hand dryer also work on the same same principle, that the hand dryer that works on electric power supply, and when we keep our hands in front of it, it will not automatically dry our hands by blowing hot air, irrespective of how much our hand is dried. So electric hand dryer will not check whether the amount of moisture in our hand is how much. So if we just put our hand, it will be on. If we just take our hand out, and then in that case the hand dryer will be off. So the next example is a bread toaster. So the toasting machine runs as per our adjusted time period, and it toasts the bread pieces irrespective of the toasting completed or not. Same, the word processor is working as it is not going to check whether our desired output is achieved or not. So the open loop control system can be used in a practice only if the relationship between input and output is known. If there are neither our internal or external disturbance. Okay, in case of internal and external disturbance, your open loop control system will not going to work properly. So clearly such system are not feedback type of system, or we can say not closed loop kind of system. One thing we have to note right here, that any control system that operates on a time basis, it's generally known as a open loop control system. So let me just write down, because this is one of the important characteristics of open loop control system. So any kind of control system that operates on time basis is open loop control system. For instance, let us take an example of a traffic control. So traffic control by means of signal operated on the time basis, and another example of open loop control system. Okay, so I hope it is clear. Let us discuss the advantages of open loop control system first, and then disadvantages. So first advantages is very clear. The open loop control system are very simple in design and easy to design. As far as the cost criteria will concern, the open loop control system are cheaper and other type compared to other type of control system, that is CLC. Okay, closed loop control system, CLCS. Maintenance of open loop control system is very simple, because the number of number of elements connected in open loop control system are very less with respect to closed loop control system. The system is not such a robust. Okay, that is why also maintenance of such kind of system is simple. These kind of system are stable for some extent of time. Now the stability of open loop and closed loop control system will deal with in the later chapter, but right now the stable will be open loop control system. As far as closed loop control system, it will be more unstable. but here we are assuming that if there is no disturbance, in case of disturbance the open loop control system will be uncontrollable. Okay, so it will be unstable. Now these type of systems are very convenient to use. That is why whatever the equipment we are using at our household are generally open loop control system. Okay, because it is very convenient for us to use. Now there are so many disadvantages of open loop control system. The first one is the bandwidth of open loop control system is very less. The non-feedback system doesn't facilitate the automation of process. The third one is open loop system are inaccurate in nature, as their output is affected by some of the external system disturbance. The non-feedback systems are unreliable, and fifth is it cannot correct the output deviations automatically. That will be possible in case of a closed loop control system. Okay. Now let us start our discussion of closed loop control system. This is very much important. So a definition says a system that maintains a pre-described relationship between the output and the reference input by comparing them and using a different as a means of control is called feedback control system. The definition is very clear that whatever the output we are getting, we are again fed to our signal, where both of the signal are going to be compared with either to your actual output and your program output is going to be it is going to be compared right here, and it will generate one error signal that is going to be fed to controller, and controller will try to correct those errors, and afterward we are getting our the whatever the output we want to achieve. Okay, so this is the block diagram of closed loop control system. Here you can see there is a forward path, and here is the feedback path. Feedback path. Okay, so there is no feedback path in case of open loop control system, but in case of closed loop control system the feedback path will be there. Now an example would be room temperature control by a system. By measuring the actual room temperature and comparing it with reference temperature, the thermometer turns the heating or cooling equipment, and it will switch your AC or heater on and off and going to achieve the desired temperature. Let's say you want your room temperature to be 20 degrees centigrade. Okay, now this is your input that you have given to the system, and at output your room temperature is, let's say right now it is 20 degrees centigrade. Okay, so your output is 25 degrees centigrade, your input is you want to achieve 20 degrees centigrade. So this 25 degrees centigrade will be again fed to your comparator. Your comparator will check your programmed variable and your output variable is same or not. Here in this case you can see there is a difference of minus 5 degrees centigrade. So that error signal will be going to fed to controller, that we have to just increase our temperature. Okay, so in that case the temperature will be increased and your temperature will be 25 to 20 degrees centigrade. Okay, now once the 20 degrees centigrade is achieved, it is again going to fed back to your comparator. In that case now the error will be 0 degree centigrade. Okay, so this is what the simple function of a closed loop control system. Now feedback control system are not limited to engineering only, but can be found in various non-engineering field as well. So let us consider our human body is highly advanced feedback control system. Your body temperature and blood pressure are kept at a constant rate by means of a psychological feedback. In fact, we can say a feedback perform a vital function in entire universe or for our human life too. it makes a human body relatively insensitive to external disturbance. Okay. Now, feedback control systems are often referred as a closed loop control system too. In practice, the term feedback control and closed loop control system are very similar. Okay, so you might use closed loop control system, or you can also use feedback control system. So we are going to let us take another example to understand what is a closed loop control system. So here you can see the automatic tank level controller system, and here we have defined the different terminologies. H is your controlled output, float is a feedback path element, reference input, and so on. Okay, now let us understand first the working of this, and then we'll try to understand all this the terminology that we have already discussed. What is controlled variable, what is manipulated variable, what is your error signal. Okay, same way you can also take a simple example first. Okay, so take the same example of a man who is driving a car, and what are the disturbances, how we are controlling the speed at particular 80 kilometers per hour that we have taken in previous lecture. Okay, and you are going to find what is controller, what is process, what is your feedback path, what is your comparator. Okay, what is your input signal, what is your output. You can do with this. That might be the simplest example. Here it's a little bit complex example. Okay, so that is a simple tank level control system that is shown right here. Now this control system can be maintain the liquid level H. Here you can see that it should be maintain the liquid level H, that will be our controlled variable. So our output, our aim is to maintain the level of this liquid in this container should be up to this level. Okay, that will be given by H. So this is our controlled variable. Okay, now within accurate tolerance of desired level, so even though the output flow rate of the valve is varied with this, okay, so output is going to vary. In that case also we want to achieve this much of level of water in the container. Okay, now the liquid level is sensed by the float that is right here, and feedback path element is also connected to float. Okay, this is your feedback path, this will be your forward path. Now this float is also associated, or the joint with position slider arm, that is B, on a potentiometer. Here you can see a potentiometer. This slider arm A of another potentiometer is positioned corresponding to the desired level of H. So here it is already predefined that we want to achieve at this point. If the potentiometer is at this point, the level of water will be H only. Okay, so we have to maintain the position of B in such a way that this tank will be full. If the potential, if the position of B is different, in that case the level of container will be different. Okay, so when the liquid level rises or falls, the potentiometer, or we can say our error detector, give an error voltage, that is actuating signal proportional to the change in the liquid level. Now the error voltage actuates the motor. Okay, so this error voltage, whatever the error voltage is generated, it is going to actuate your motor through the power amplifier, and that is our controlled element, which in turn condition the plant and decrease or increases the opening of the valve V2. Okay, so the motor is going to control our valve V2 in such a way our your potentiometer will detect the error. Now the thing is that once the control system is automatically attempts the correct to any deviation between your actual and desired level of water in a tank. So if your float is at the down position, your slider will be at somewhere right down here, and it will generate some error voltage that is going to fed to motor, and that will open your valve V2 accordingly, and that will pour water into this container. So ultimately this is your feedback path, this is your forward path, here you can identify that h is your controlled output or your controlled variable, because we want that level of the container should be at some point, that is h point. Now what is float? Float is nothing but a feedback path element. Okay, it will be take the feedback from this container that how much the water is filled in the tank, and it will be fed back to the potential. What is H? Capital H is nothing but your reference input. Okay. What is potentiometer? Potentiometer is error detector, or we can say the comparator. It will compare the position of A and B, and it will generate error voltage signal accordingly. What is error voltage? It is nothing but your error signal or actuating signal. We can say error signal or actuating signal. Okay. What is motor drive? It will be your controller. So you can just put all these things in the block diagram of closed loop control system. So this is one example of closed loop control system. Let me give you another example of closed loop control system, that is automatic steering wheel control system. So here our aim is to go in the direction that is followed by the path. The desired direction is shown by this arrow, but actual direction in that the car is going is right here. So there is angular distance between the actual direction of travel and the desired direction of travel, that is sensed by our error detector theta, that is theta. Okay, it will again fade back to our controller. In that case, it will be a man who is driving the car. He is going to suspect that the desired direction is different than the actual direction. He is going to take some action, and the car will be in the right direction. Okay, so here you can find your control variable, your reference signal, your feedback path element, what is your controller. Okay, so this is a task for you. I'll assign this as tasks. So you have to find each and everything for this example. I am not giving right here. Okay, you have to find what is your plant, what is your controller, what is your reference signal, your command signal, feedback path element, and all these things. So let us discuss some of the advantages of closed loop control systems. So very obvious that the closed loop control systems are more accurate even in the presence of non-linearity. Okay, so this is going to be more accurate, where open loop control system is less accurate. Highly accurate, as any error arising is corrected due to the presence of a feedback signal that is not present in case of closed loop open loop control system. So bandwidth range is very large. You can vary your input, and accordingly your output is going to vary. Okay. Facilitate automation in many automation industries. In every automation industries, your system will be always the closed loop control system. The sensitivity of the system may be made small to make the system more stable. Okay, so you have to check how the sensitivity of our system is. We are going to discuss what is sensitivity in next chapter. Okay, so I hope the word sensitivity is clear to you, but in the sense of control system, the sensitivity is little different, and that we are going to study in next chapter. The system is less affected by noise. Noise is it means it is less affected by error, or we can say disturbance. Okay, this system is less affected by disturbance. Now let us discuss some of the comparison of open loop control system and closed loop control system. It is nothing but the advantages and disadvantages of open loop control system and closed loop control system. They both have some of the advantages and disadvantages. Let us take a look. So there is a feedback element is absent in open loop control system. In place of closed loop control system, the feedback element is always present, that we have discussed while discussing the block diagram of open and closed loop control system. Error detector is present. Here the error detector is always present. Here it is not present. Okay, so in case of open loop control system, block diagram is only the forward direction. Here it is your forward direction, your feedback path, and your feedback path will fed the signal to compare or reference signal and your whatever the control signal will be there. Again, it will generate an error signal. This system is stable and closed loop control system becomes unstable. This kind of system is very easy to construct, and as far as feedback path or the feedback element is present, that is why the complexity of closed loop control system will be more. That is why open loop control system is economical and closed will be costly. Same for the bandwidth. Open has small bandwidth, while the closed loop control system have large bandwidth. This system is inaccurate due to the feedback path is not present, but in case of closed loop control system it is very accurate. The maintenance in open loop control system is very less. Closed loop control system has more maintenance required due to the number of equipments are more and the system is very complex. So obviously the reliable system will be closed loop control system only. These are some of the example of open loop control system and closed loop control system that we have discussed. Okay, so I think this is all about your first chapter, that is open loop introduction to control system, and in this next chapter we are going to start the mathematical modeling of any physical system, either it is a mechanical system or electrical system or a pneumatic system or a hydraulic system. So for the introduction of control system, I think this is very much clear to everybody that automatic control systems are a closed loop control system which is automatically respond to the disturbance and the variations without the presence of human operator, where manual control system are a closed loop control system but in some corrections are done by human operator. So I think it is very clear to you. So thank you so much. In next lecture we are going to start our new topic, that is mathematical modeling of physical system. Thank you so much.